Dear friends, welcome and season's greetings to you all. Today we are going to discuss about some tips for improvement in availability and performance of AFBC boilers. I am Manohar Tatvavadi from Total Output Power Solutions, Pune. First we discuss about general design aspects of fluidized bed. Based on the boiler heat duty, the amount of fuel to be burnt is decided. Based on the chemical constituent of fuel, the air required for combustion is calculated. As the combustion takes place in the bed, all the heat of combustion is released within the bed. The heat is extracted out of the bed first by the bed evaporator tubes and then by the leaving flue gases. The bed cross-sectional area is fixed based on the fluidization velocity, which will not exceed 2.8 meters per second. Some more design aspects of fluidized bed. Once the bed coil area and the bed cross-sectional area is decided, it is clear that the turn down, that is, maybe the lowering of the load or fuel, becomes difficult. Because lower the heat release rate, lower will be the bed temperature. Hence, by reducing the bed height, the bed heat transfer area immersed in the bed is reduced, so that the bed temperature is still ensured for steady fuel combustion. Additionally, compartments are designed to ensure that the minimum fluidization is achieved. Bed slumping may be done and the fuel feed and the air feed are turned off in the slumped bed. Now, with this brief discussion on the design aspects of the fluidized bed, we discuss about some tips for improvement in availability and performance of AFBC boilers. There is always a solution to every problem experienced. Yes, the tips discussed in the video are based on the operational experience of several makes of AFBC boilers in India and abroad. The tips would certainly benefit some boiler users or operators for the availability and performance improvement in the field of AFBC boilers. The tips will be useful for the reduction in overall costs. The tips will also help to improve the downtime of the system and also in the continual improvement of the design and or the operation of FBC boilers. And lastly, there is always a scope for additions to this list. The first tip for AFBC boiler bed coils. Check bed coils pitch for studded bed coils. Studs can increase protection against gross erosion but not localized erosion. Studs decrease the clearance between adjacent bed coils. Spacing of coils is to be specially addressed if studding is opted for. The increased fluidization velocity at narrow clearances decreases the life of the bed coils. Hence, bed coil pitch is very important to be checked or monitored, maybe in the shutdown of the boiler. The second tip: use optimum primary air pressure. Primary air fans, they are required for the underfeed system. The PA fans generally selected with 15 to 25% flow margins. It is necessary to keep the primary air header pressure as low as possible so that the suction effect is just the minimum at the throat. The air leakage from the feeder must be taken as a guide. Higher primary air header pressure leads to more airflow through the fuel feed points. Higher airflow would erode the bed coils faster. In addition, venturi erosion would also be faster. The third tip, replace the worn out venturi and or mixing nozzles promptly. In underfed arrangement, the fuel is fed from the bottom of the bed. As the pressure at the feed point inside the bed is 400 to 500 millimeters of water column, high pressure PA fan with mixing nozzles are used to transport the fuel inside. The air jet velocity at the throat of the mixing nozzle is of the order of 100 to 130 meters per second. The fuel particles are accelerated at the mixing chamber and the diffuser ensures the gradual return to normal line velocity. The diffuser erodes over a period of 1 to 2 years. As the pressure drop in mixing nozzle increases, more and more air is required for generating suction at the throat. Naturally, the erosion rate of bed coils will be more inside the bed. The fourth tip, some manufacturers adopt push-fit nozzles over the distributor plate. Further, a castable refractory is laid over the plate. The castable gets broken during service due to thermal expansion. This leads to leakage at the air nozzle base itself. Such leakages lead to not only bypassing of more air from such locations but also lead to defluidized zones. This can happen near bed ash drain points. Now the fifth tip, avoid continued operation with troubled bed. A fluidized bed may get clinkered when there are disturbances in boiler operation. For example, when there is no coal in the bunker, the operator momentarily reduces the airflow in order to reduce the bed quenching. At this time, it is likely that the bed defluidizes at some zones. The average particle size is always high compared to startup bed material and hence defluidization chances are more when the airflow is reduced. Once the bed is known to have clinkered, steps are to be taken for immediate clinker removal. This may be possible by increasing the drain rate from the clinkered bed. A bed clinkering can be figured out from the differences between the bottom and top bed temperature readings. Tip number 6. Do not operate the boiler with choke primary air lines. Primary air lines choke up when oversized fuel is fed or when the compartment damper is opened before operating the PA damper. Due to this, the fuel nozzles get distorted. In running boiler, no one can guess what extent of distortion is. If the fuel nozzle cap is distorted, the fuel air mixtures may target the bed coil and lead to premature failure. Distorted nozzles are to be replaced immediately. Stainless steel fuel nozzles offer better protection when it comes to bed coil life. Tip number 7. Reduce the chances for startup clinkers. Fluidized beds may be started compartment by compartment. When the first compartment is started, one must ensure that there is a good amount of bed material to prevent the fuel spillage to the adjacent compartment. The primary air pressure should be bare minimum. Excess primary air pressure spills more fuel to the adjacent compartment. The primary air pressure requirement will be less since the bed height will be less during startup. When the fuel spill is more, a border clinker is likely to form. Excess mixing airflow also leads to more spillage. It is necessary to keep the primary air dampers of adjacent compartments in closed condition. Tip number 8. More primary air and less fluidizing air. By virtue of design and or operating load, bed material settles along the wall sides. This leads to throwing of bed material along the wall to the coils. This happens where fuel feed points are closer to wall. When the frequent load turndowns are expected, the bed plate pressure drop has to be designed for ensuring a minimum bed plate pressure drop of 75 mm of water column. Operating at lesser delta B would lead to pockets of wounds. Tip number 9. Bed coil to fuel nozzle clearance. The designer has to ensure a minimum clearance of 150 mm from fuel nozzle cap top to bed coil to safeguard the bed coil against erosion. At times, due to faulty erection, the clearance may be less, leading to premature bed coil failure. Tip number 10. Leaky compartment dampers lead to partial fluidization. Spilled fuel from adjacent operating compartment would lead to clinker formation and further growth of clinker. Hence, dampers will need replacement. Butterfly dampers with proper seals would be the ideal choice to solve the clinker problem. In ordinary flap type damper, sealing strips would help bring down the leakage. You can see the figure in the next slide. Sealing strip for circular dampers. In the figure, you can see the red circle sealing strips provided for the sealing. These sealing strips in good condition would ensure a complete stoppage of air leakage. Tip number 11. Care to use the air vent wall in idle compartment. Slumping of a compartment is necessary to take care of load reduction and while startup of the combustor. There can be clinker formation if the fuel spillage is present in the idle compartment. In certain boilers, the fuel feed point may be close to the border of the adjacent compartment. For the clinker to take place, there should be airflow in the idle compartment. The compartment dampers may not be leak proof. For this reason, automatic air vent valves are provided in compartment air box to enable venting the passing air from the compartment damper. If the valves are to be manually operated, the same must be done. Needless to say that the leaky damper will have to be attended as early as possible. Care to use the air vent wall in idle compartment. You can see the figure, and in the figure you can see that the vent walls. The blinking dots will show you that those are the vent walls. Those are to be opened if the compartment there are leaking dampers in the compartment. Tip number 12. Ensure proper fuel particle size. Ensure proper fuel particle size. Improper fuel sizing affects the bed particle size. Improper screen mesh sizing, coarse particle separation in bunker, worn out crusher hammers can lead to oversized fuel particles. Oversized fuel particles are found to accumulate near the fuel feed points, leading to defluidization. The air jets upwards once this happens. Because of this, bed coils erode locally above the fuel feed point at this time. Tip number 13. Instrumentation. Check the adequacy of instrumentation of fluidized bed. In the absence of bed temperature indications, air box pressure and bed pressure, the operation of the fluidized bed is risky. When such instruments are compromised, no one can claim that the bed is perfectly okay at all places. It may be possible to assess the condition from the bed material drained from the ash drain pipe, but the same will not be proper for bigger beds. Failed thermocouples, burnt compensating cables, defective temperature indicators, are to be replaced at the earliest opportunity to prevent bed coil erosion. Well, thanks for watching. Hope you have enjoyed this session. We will discuss about some more details about the excess air factor in AFBC boilers in our next video. Like, subscribe and share. Total output power solutions. Thank you.